Hello learners. Let's begin with a simple observation. Have you ever seen a beam of sunlight streaming through a tiny hole into a dark room, with the dust particles beautifully dancing inside it? That glowing path is scattering in action. Scattering is simply the process of absorption and then re-emission of light energy by particles in its path. Rayleigh was the first scientist to study this phenomenon in detail, and thanks to him, today we understand why the sky looks blue or why sunsets are red. Now, how does scattering really work? Air molecules, which are smaller than the wavelength of light, absorb incoming light energy and then re-emit it. But here's the catch: the scattering isn't the same for all wavelengths. Shorter wavelengths, like violet and blue, interact more strongly with these tiny molecules. Longer wavelengths, like red, are hardly disturbed. That's why different colors of sunlight don't scatter equally in the sky. The intensity law of scattering tells us that scattered intensity is inversely proportional to the fourth power of wavelength. In simple words, shorter wavelengths scatter much more strongly than longer ones. That's why violet light, with a wavelength of about 4000 angstroms, scatters the most, while red light, with a wavelength of about 8000 angstroms, scatters the least. In fact, violet scattering is nearly 16 times stronger than red scattering. This is the reason why we see dominance of blue shades in scattered light, for example, in the color of the sky. So, the rule is simple: shorter wavelengths scatter far more strongly than longer wavelengths. Now let's apply this idea to the atmosphere. When sunlight enters the atmosphere, the shorter wavelengths, violet, indigo, and blue, scatter in all directions. Red, on the other hand, sails through with very little scattering. But then you might ask, why isn't the sky violet? Great question. The reason is our eyes are less sensitive to violet. So the scattered blue dominates what we see, giving us that beautiful blue daytime sky. Let's do a quick calculation together to see this in numbers. Take violet light at wavelength 4000 angstroms and red light at 8000 angstroms. Using Rayleigh's law, the ratio of violet to red scattering is 8000 divided by 4000 to the power 4. That's 2 to the power 4, which equals 16. So violet light is scattered 16 times more strongly than red light. This one calculation explains so many natural wonders: the blue of the sky, the reddish glow of the setting sun, and even why the moon can sometimes appear yellowish when low on the horizon. So let's wrap it all up. Scattering is the absorption and re-emission of light by molecules and dust. Rayleigh's law tells us that intensity varies as 1 by wavelength to the power 4. This means shorter wavelengths scatter more, violet the most, red the least. That's why the daytime sky is blue, while sunsets and sunrises glow in shades of orange and red. Next time you enjoy a sunset, remember, it's pure physics painting the sky for you.